In this video, I want to talk about the relation between Cartesian coordinates, our standard x, y rectangular coordinates, and polar coordinates. And whether you're converting from one point or taking a point in one form and converting it to another, like you've got some point x, y, and you're trying to convert it to some polar coordinate r theta, or maybe you've got an equation in rectangular coordinates or perhaps polar coordinates, and you're trying to convert that thing into some equation that has only x's and y's in it, all of it can be done using a simple diagram. A lot of times books will tell you, okay, here's the formulas you need to know. X is equal to r cosine theta, y equals r sine theta, tangent of theta is equal to y over x. And that's all absolutely true. And that's all incredibly helpful for doing these conversions. Those are the tools we need. Personally, I find it that trig already has so many things to memorize. I don't think this should be presented as an additional set of formulas to know. We already know all this, and it's coming right out of a simple right triangle here. Actually, let's do it this way. Suppose I'm on an xy axis and I've got some point out here, xy. So we know we could get there from a Cartesian point of view, going x to the right, up y. That's the rectangular way of thinking. Or we can go there a polar way of thinking, which is to rotate some angle theta and then walk some distance r towards it. But if you look at the picture here, it's just a right triangle. And in fact, it's the same right triangle picture you first look at when you learn your trig functions. So from this picture, if I just want to rely on good old SOHCAHTOA, I could see that if I were to take cosine of angle theta, it would be adjacent over hypotenuse, which is exactly the point definition of the trig functions, which you probably have seen. Similarly, y is sine of theta. Oh, I'm sorry. Sine of theta is y over r, right? The opposite over hypotenuse. And tangent of theta is y over x, opposite over adjacent. So using SOHCAHTOA or the point definition, however you like to think about it, you already know all of this, which means you already know this. That's exactly where they come from. See, all they're doing is they're taking the r here and bringing it over to the other side. They're multiplying both sides by r. So here you get that r cosine theta is equal to x. You multiplied both sides by r here, you'd get r sine theta is equal to y. Okay, and we've already got that tangent of theta is y over x. So again, these are incredibly useful for making the jump between a rectangular way of thinking to a polar way of thinking, or vice versa, whether it be point by point or whole equations at a time. But you don't have to think of these as something new. You already know all that. That's just straight from the definition of our trig functions, or the way I kind of remember it is always just going back to this basic diagram in SOHCAHTOA. Okay, hope this helps. Good luck.